Hello, today I am going to continue my discussion on discrete distributions, that is distributions where the random variable or the support of the probability distribution is countable. That is, it can be finite or a countably infinite set, and we have discussed Bernoulli, binomial and Poisson distributions, and today I am going to discuss geometric and negative binomial distribution. So a geometric distribution is a discrete distribution where the random variable is taking non-negative integer values 0, 1, 2, 3 with corresponding probabilities as defined here, and as you can see, this is a geometric series, so hence the name geometric distribution. P represents a fraction between 0 and 1. Now, where does this distribution occur? Suppose a coin is tossed until head occurs, until you get a head. So that is the first head. And then let x denotes the number of tails preceding the head. So what can be the possible outcomes? You remember this experiment in the context of an example of random experiments with infinitely many possible outcomes, right? So here it can be tail, or it could be a head. So in that case, k would be 0. It could be a tail head, k would be 1. It could be tail head, then k, the number of tails would be 2, and this in this way it is so on and so on. And these would be if k is 0, then it is the chance of getting a head, so it will be p. And then if k is 1, then it is tail head, so 1 minus p, chance of tail into a chance of head p. In this way, probability of, so we are computing probabilities in a multiplicative way. So if I have got tail head, then it will be 1 minus p into p, in this way. So geometric distribution represents the number of distribution of the number of tails until we get the first head. Now this model can be generalized. So suppose I toss a coin until the rth head occurs, where r is any number greater than or equal to 1. Then the number of tails preceding the rth head, that will follow this distribution. So you see, this is similar to the geometric distribution. If you put r equal to 1, then it will be kck1. So you will get the same formula. So the negative binomial distribution is the generalization of the geometric distribution in the same way as binomial distribution is a generalization of the Bernoulli distribution. So this is geometric distribution with parameter p, and this is negative binomial distribution with parameter r and p. So negative binomial distribution with 1 and p is geometric distribution. Now I leave it as an exercise for you to verify that this represents a probability mass function. That is, the sum of these when you take over k is indeed 1. So for that, what you need to know is what is the expansion of, suppose x is a number between 0 to 1, then you need to know what is the expansion of 1 minus x raised to the power, let's say power is, I am writing in this way, this is LaTeX notation, to the power minus r. So this would be, this expansion you need to know. So what is the general, this is 1 plus rx plus r into r plus 1 by 2 into x square and so on, infinite series. So the general term looks like this. So if you sum over all values of k, p is a constant, it will come out, and then let x be 1 minus p, then that sum would be 1 minus p raised to the power minus of r. So 1 minus p is 1, so that's how it is 1. Okay, so negative binomial and geometric distributions are similar, where when you consider it tossing the coin until you get one head, that is geometric, and when you consider tossing a coin until you get R heads where R is more than 1, you get negative binomial distribution. So binomial and Bernoulli are one type of distributions. Here you toss the coin finitely many times. So Bernoulli is tossing a coin 1 and counting the number of heads. Binomial is tossing a coin n times, n is fixed, and they are counting the number of heads. On the other hand, geometric and negative binomial are distributions obtained by tossing the coin as many times as needed in order to get a specified number of heads. So these are distributed. So they random experiments with different stopping rules lead to binomial and binomial or negative binomial distribution. So in a binomial distribution, a coin is tossed finitely many times. In a negative binomial distribution, a coin may be there is no upper limit on the number of tosses. A coin will be tossed until we get a specified number of heads. In a Bernoulli distribution, the number of tosses is fixed, so the number of heads cannot exceed that number n. Here, the number of tails preceding the rth head. On the other hand, for negative binomial distribution, there is no upper limit. It could be as large. It could be 0, 1, 2, so on. You cannot put an upper limit. So there are infinitely many possible values. And so this is the important distinction between binomial and negative binomial distribution, or geometric or the Bernoulli distribution. So we have discussed 5 important distributions. Poisson is really an approximation of the binomial distribution when n is large and p is small, in such a way that n into p is proportional. N into p is close to some positive constant lambda, that is p is like 1 over n. It may not be exactly, but it is some multiple of 1 over n. So so this is the basic idea of these 5 basic discrete distributions. We will talk more about them later. So you know expectation of random variables, right? I would leave as an exercise: compute expectation of x where x follows binomial Poisson negative binomial distributions. Binomial is a simple random variable, so there it will be just values into corresponding probability sum. Poisson and negative binomial would represent discrete random variables with infinitely many values. There also the formula is same, sum over values into corresponding probabilities. So I leave that as an exercise. Thank you.